Today we're going to focus on simplifying algebraic expressions with integers. So our learning target is listed here. It says, I can simplify algebraic expressions that contain negative numbers. So we worked on simplifying algebraic expressions earlier this year with positive numbers. Now we're going to be working with integers, which are positive and negative numbers. Here are kind of our steps. We always want to apply the distributive property first and then combine like terms. We worked on the distributive property last lesson. The first thing I'm going to do is distribute this negative 7 to everything on the inside of parentheses. So negative 7 times v is negative 7v. And then we can read this as negative 6. We can copy, change, and put plus a negative 6, or we can do minus a negative, but that when we use copy, change will end up being a positive. So it's totally up to you. I'm just going to read this as a negative symbol. So this subtraction sign, or I'm going to copy, change, so it's a negative. Negative times a negative is a positive. And so I have positive 42. And then at the end here, plus 8v. Now when I go to combine like terms, I've got like terms have the same variable and the same exponent. So negative 7v and 8v. Same signs add and keep, different signs subtract. So these two have different signs, so 8 minus 7 is 1. Keep the sign of the higher number, in this case that's positive 8, and then you'll be exact. And then 42 is its own like term. V and 42 are not like terms because they don't have the same variable and the same exponent, so this is in simplest form, 1v plus 42 or v plus 42, since 1v is the same thing as v. I would accept either answer. On this next example, again, we're going to apply the distributive property first. We're going to take the outside number and multiply it by everything on the inside. 3 times 3y is 9y, minus 3 times 2 is 6, minus 14y, plus 5. Again, we always want to read this negative or this subtraction symbol as a negative, or we can copy, change, which means we copy all of that, change, or add the opposite. When I look at my terms now, I've got 9y plus negative 14y. When signs are the same, we add and keep, but in this case, signs are different. I've got a negative and a positive. So different signs subtract. 14 minus 9 is 5y. Keep the sign of the higher number, then you'll be exact. So in this case, the higher number is a negative, so this should be negative 5y. And then I've got minus 6 and plus 5, or negative 6 and positive 5. If we copy, change, you still see that as a negative, so that's why we can read the subtraction symbol as a negative if we like. Different signs, we subtract. So 6 minus 5 is 1, and then keep the sign of the higher number, which is negative 6, then you'll be exact. So we've got negative 5y plus negative 1, or you could have negative 5y minus 1, since the minus sign kind of can be read as a negative. Either one is fine. So here is my simplified form. Again, when we simplify algebraic expressions, we want to apply the distributive property first, and then we want to combine like terms.